Hey guys, welcome. Let's go ahead and get to our review, part one. The diagonals of a parallelogram. Again, if we know all of our rules, we can figure out which one of these it is. The diagonals of a parallelogram will bisect each other. What's kind of interesting is it lists all that apply. So a rectangle, a square, and a rhombus are all parallelograms. So they're going to also share that piece. Okay. Rectangle. Rectangles also have congruent diagonals, so we know that's going to be true for that. The other two are not true. A square is going to actually possess all of them, so it's A, B, C, and D. And a rhombus has perpendicular bisectors, and they also bisect opposite angles. Diagonals of a trapezoid, there's actually none that match up with a trapezoid. But an isosceles trapezoid does have congruent diagonals. Okay? True or false? Opposite sides of a parallelogram are congruent. That is true. Consecutive sides of a parallelogram are congruent. That's false. They are supplementary. They add to 180. Base angles of a trapezoid are congruent. That is also false. That would be only true of an isosceles trapezoid. The measure of median of a trapezoid is equal to 1/2 the sum of the bases, or B1 plus B2 divided by 2. That is true. Okay. Number 11, B equals 63. Sorry about that. I got some updates quick. So 63, we're going to go ahead and find the measure of the other angle. Go ahead and draw a parallelogram. I just label it in clockwise, but as long as you start one place and just keep going. So 63 is right here. Remember, opposite angles are congruent, so this would also be 63. And then consecutive angles add to 180, so that would be 117 would give us consecutive angles that add to 180. Okay. This shape is a square, so ABD, again, the middle letter is the vertex, so the angle has to be right there. ABD, A, B, and D, right there in the vertex. Remember, these are all 90, and these also get bisected, and they're 90, so this has to be 45 degrees. BEC is this angle right here, 3x plus 9. Again, all the diagonals are 90, so we just do 3x plus 9 equals 90. Subtract 9 and we get 81, I believe, and then divide that by 3 and we should get 27. And the perimeter of the square is 56, and we know one side is CD, which is 2x plus 4. Now I don't know all the sides individually, so what I would do is I'd take 56, and since it's a square, I know all these are equal. I could take 56 and divide by 4, that would give me 14. So I know each side is 14, which means 2x plus 4 should equal 14. Subtract 4 from both sides, divide by 2, x does equal 5. Our next shape is a parallelogram. JN is this segment here, and then JL is the entire segment. So if JN is only half of it, but JL is the whole thing, I'm going to need to double this. These two pieces are congruent because they bisect. So I can double 11 and set it equal to 4x minus 2 because JL is the entire piece here. That's going to be 22 equals 4x minus 2. Add the 2. 24 equals 4x. X is going to equal 6. MN is this piece, NK is this piece. Those two are congruent, so we can go ahead and just set those two equal to each other. No need to double anything or any of that business. I'm going to go ahead and subtract 2x and add the 9 over at the same time. And we're going to get 3x over here, and that will equal 12. X is going to equal 4. Now it's told me to find NK, so I'm going to plug this back into NK. That gives me 20 minus 9, which NK is going to equal 11. This next one's 17. We are basically setting up the diagonal pieces congruent to each other. So we'd have x squared equals 2x plus 8, and y squared equals 81. We're not going to have a factoring question for right now. I'm going to skip it. I don't want to cause any confusion. Number 18, JML is 84. I'm going to go ahead and just redraw the shape right down here just to make it a little easier on our eyes. That's N, K, L, M, J. J, M, L. So this whole angle here is 84. Find M, J, K, this whole angle up here. These two angles are supplementary, so I basically just have to say what would add to it. And I believe that would be 96 plus 84 would make 180, so this would be 96 degrees. Again, they have to add to 180. All right, JLM over here is 29 degrees, and JNM is 80 degrees, and we want to find JKN, which is right here. So we're going to ignore these two values. They're no longer a part of this problem. Notice that we do have a special relationship here. These are parallel lines right here, and then this would be a transversal, which means this 29 down here in the corner is also going to be the 29 degrees up there. And if this is 80, we know this would be 100. That's a linear pair right there. So we get 29, 29, and we're going to go ahead, and I'm going to zoom in a little bit. Actually, I think we're a little too far out. Almost screen went blank on us. 29 and 29, like I said, alternate interior angles, 80 and 100 are linear pairs. So we're going to add these two together and x to find our value. And we're going to set equal to 180 because you see the triangle here. There's a triangle created with all three of those angles in pink. And we can go ahead and solve for that. And I believe we are going to get 51 degrees. So the measure of JKN equals 51 degrees. Okay. All right, number 20. Now we're talking about a rectangle. We have PR. PR is the whole thing. QS is the whole thing. And we do know that diagonals are congruent. So we can just set these two equal to each other, make life easy. Subtract 3x, add the 4. Okay. Just doing some basic math, x will equal 2. So find x, that was step 1, and then find TQ right here. Well, remember, all of these are congruent, so if I can find what QS is, I can divide it by 2. So 3 times 2 plus 8 is going to give me QS. That's going to be 6 plus 8, so QS is going to give me 14. This would be half of it, because we cut it in half. So TQ equals 7. All right. QPT, QPT, so this angle here is 36 degrees. And TQR is this angle here. We're trying to find it. So recall that we have isosceles trapezoids. So this angle and this angle are actually congruent because of our isosceles trapezoid. I'll draw the isosceles trapezoid in blue right here with the two congruent legs and two congruent bases. So that makes this 36 over here. Okay, and these two angles, remember, every angle in a rectangle is 90. So 36 plus x should equal 90. And that will give us a value of 54. So angle TQR is going to be 54 degrees. What type of triangle is PTS? That's going to be an isosceles because, well, rectangles make up isosceles triangles. All right, first step, we're going to go ahead and just label a quadrilateral. So I'm going to pause it so you don't need to watch it. I'll just up here for you. Okay, so here's our shape. First thing, guess. And I think the pretty easy guess here is going to be a rectangle. My biggest concern, though, do I have 90-degree angles here? To find that, I'm going to use the slopes. And so QU is going to be a rise of 1, 2, 3, 4. So I rise 4, and I run 6, 10. So I get 4 over 10. Always want to reduce that. That's going to become 2 over 5. Okay? And then QD is going to be a run of 2. I'm going to go down 5. Okay? So right here, these two are opposite reciprocals, so I do know it's perpendicular. Okay, so in this angle right here, I do know it's going to be a 90 degree. Okay? Good news is, it told me it's going to be parallelogram, rectangle, rhombus, or a square, so I already know that opposite sides are going to be congruent. So legitimately, I already know these are all 90 degrees, which means it probably is a rectangle. The only last thing you have to do is check the distance, so you need to use the distance formula to check that. It says 2 consecutive sides, so consecutive sides, an example of consecutive sides would be like AD and UA. They're right next to each other, so if I found the distance of those two. If they were different distances, then we would be able to go ahead and say, yes, these are different. So I'm going to go ahead and find the lengths of those. So I'm going to rewrite -3, -2 down here, and A and U. Those are the only 3 points I'm actually going to use in the distance formula here. So dA is going to be, so we're going to take, when we look at this, let's just use, we're going to use A twice, so we'll use this as my x1, y1, and this is my x2, y2. So x2 minus x1, so that's -3 minus 7, and then this is going to be -2 minus 2. That becomes -10 squared, and this is going to be -4 squared. That's 100 plus 16, so we get 116, the square root for dA, which is relatively large. Okay, we're going to do the same thing now for UA. I'm expecting this to probably be smaller. We'll use this as my x2, y2. And we're going to do 5 minus 7 squared plus 7 minus 2 squared. That's going to be -2 squared, or 4. This is going to be positive 5 squared, which is 25. So we're going to get UA equal to the square root of 29. So they're different lengths. They're not the same. So we know this is a rectangle. Okay, explain your answer in words. Well, we have perpendicular sides, and we have 2 sides that are not congruent, that are consecutive. Okay. On the back, rhombus. So HRO. HRO is this angle here, 3x minus 1, and RHO, this whole angle here, is going to be 80 degrees. Okay. Find x. Remember, these are going to go ahead and bisect. So I know that that's 40, and I know that's 90. Okay. So we can actually go ahead and just set these two equal to 90. And that's going to subtract and add, so we're going to end up with, I believe, 51 equals 3x. Divide by 3, x equals 17. Okay, again, I used the fact that these were perpendicular. The perimeter of rhomb is, find the perimeter of rhomb. So we get RH and RM. Remember, sides are congruent, so I can just set those equal to each other. Subtract that, it gives me x, add x equals 4. Now we need to actually find one of the sides. Let's do RH. It gives me 8 plus 3, which is going to be 11. So if one side is 11, I could go ahead and write all of them in. It's going to be 11 plus 11 plus 11 plus 11 plus 11, which is going to be the perimeter of 44. Alright, last one. Isosceles trapezoid. AB is 9, CD is 25, find EF. All I gotta do is add them together and divide by 2. And that's going to give me 17 for EF. And then they want me to do the same thing basically, but this time I'm given different variables. So AB is 2x plus 3 plus, I'm going to do 6x minus 9. That's whole divided by 2 equals 13. I'd rather multiply both sides by 2 to make my life a little easier. I'll combine those like terms, add the 6 over, and then divide by 8, and we should get x equals 4. Okay, And last one, we have angle A equals 118. Find angle C. Remember, base angles are congruent, and these two are same side interior, so I just have to do 180 minus 118, and we get 62 degrees. Okay? All right, that was part one. We'll come back with